Anybody get out and use a telescope recently?
Not in a while.
Oh, I've used the that triangular sunspot projector. There's been enough sunny times this weekend, and it was great. People walking by my house were coming to look at it. It's such a good outreach tool.
It is. It's great.
It's amazing, and there's some really nice spots this weekend.
Yeah, I was wondering if it was actually easily reproducible. They're quite expensive. I think they're in the $300 to $400 range. But I just wondered whether, if you were handy, whether you could actually make one easily.
Small hole in a cardboard box works.
Yeah, it does. This one's a little bit more refined than that. This one has optics in it.
Yeah.
It's a little bit more refined than that.
I mean,
Much better image.
It's a folded telescope. It's got an objective. It's got a eyepiece, and then it's a projector. I mean, it's exactly the same as a linear one. Just happens to have 3 mirrors.
Maybe it's something for the makers group to look into. Maybe it's something that's easily reproducible.
Speaking of the makers group, I actually did some making on the weekend, and actually I used my telescope, but it was cloudy. I made an artificial star, and then I was collimating last night using my artificial star. So.
Oh, cool. You just use a piece of metal and poked a hole in it, or?
I did a microscope slide and some aluminum duct tape, and then poked a tiny hole with a pin.
Okay.
And then a collimating lens and a high power LED in behind all of that.
Did you clean up the hole, or did you not get that?
Sorry?
Let's see. Did you clean up the hole? Like, did you buff it to make sure it didn't have any burrs, or?
It seemed pretty good. I had it about 100 feet away, and I was getting really nice diffraction.
Yeah.
So, because I need to collimate my scope, and I realized I've been having some issues that could easily be collimation issues, and including some of my planetary issues. And so, but spending a bunch of time collimating on a beautiful clear night seems like a waste of time. So I was like, can I do this some other way? So.
Yeah, exactly.
And also at night, you want to collimate on like Vega, which of course that means your adjustment screws are 7 feet in the air, and I'm only 5'5", and the math doesn't work. So if I can have the telescope horizontal and access the screws with my artificial star 100 feet across the yard, that makes it a lot easier.
Oh, now you just need remote. You need motorized collimation screws.
That'd be even better, yeah. But that's the next step. I'll leave that for.
That's the opposite to the Newtonian, where on an equatorial mount you've got your one ear in the ground when you're trying to collimate the screws.
Yes.
You tweak it and then you look. You get up and down an awful lot looking at the eyepiece, and then
That's
going down.
what lasers are.
Yeah,
for.
lasers. I got a laser. It makes it so easy for minute.
Having a second person helps.
Yeah.
Yes.
Second person, absolutely.
Which reminds me, Randy, one of these days I've got to get my little crosshair collimator back.
Absolutely. You know how many times I've thought of that? I'm sorry.
That's okay. I haven't had a need for it yet.
I know exactly where it is.
The way that Roman built the secondary holder and the primary mirror mount, it doesn't go out of collimation much. It would take a ride up Cobau to loosen it, as I found with my old 8-inch, that I had to have that tool whenever I went up to Mount Cobau, because the washboard in the road generally threw the mirror out just on the trip up.
Good evening, everyone. It's just coming up. Just wait a moment or two, but I just wanted to check in. I have people presenting tonight. Marjie, still good? And Dorothy? Yeah. And Randy, you had some things for us, yeah. Reg, did you have time to put something together or not yet?
I did.
Okay. And we have a couple of photos from Edmonton, which I have, and David with what's on the schedule for this week. Does anybody else have anything that they wanted to share?
I have a couple pictures I took in October that I haven't shared yet. Sure. They're on Zenfolio, but
yeah, tell us about them. That'd be great.
Yeah,
I'll just give a moment or two. And thanks to our speaker finding group there, we have a few more people lined up, I think, to give us talks. So I think we have somebody for November and somebody for January, as far as I remember. So that's very
Potentially
good.
February.
Oh, very good. So that is very nice.
Yeah, I noticed last week we had quite the attendance.
That was, yeah, that was one of the biggest nights we've had for a long time. So
Yeah, I counted 31. Is that accurate?
I had the total we got up to was 39 at one point.
It was quite
Good.
high.
That was, other than our AGM, I think that was the #1 night we've had since we've been doing this by Zoom. We've gotten into the 30s a few times, but not almost 40. And other than, as I said, we had, according to my count at the AGM, we had 50, what was it here? Where 53. So that's been our biggest Zoom night ever. So somewhere around there, yes.
I understand the guys in Edmonton are actually considering an in-person meeting in the next month because they're going to baptize the old Queen Elizabeth Planetarium, which the city has refurbished. They're going to start holding their meetings there instead of the Space Science Center.
Oh. So what is the use of, what are they doing with the building otherwise? A meeting center then? Is it?
I think it's just going to be a display type building. I don't, for me, it's a historical building, and they did a very nice renovation job apparently.
Hmm.
It had been sitting vacant for like 20 years.
Oh, so probably needed quite a lot of work then.
Yeah, it wasn't in very good shape. We looked at it. I looked at it some time back when we were thinking about trying to prod the city into doing the restoration. They finally got around to it. It's a beautiful little building.
I used to go there when I was a kid.
Yeah, you would. Yeah.
I
So would
remember
Frank and
being-
Lodi.
Very good. Well, I think we can get started. So welcome to the last Astro Cafe of October. And thank you for joining us this evening. So first up, we'll have Marjie.
Okay, I'm going to share the screen. Oh yeah, push share. That's a good idea. Okay, next in the series of Canadian women astronomers. This is Dr. Victoria Kaspi.
We don't see it.
We're stuck on your Zoom page. Yeah, we've got your browser page only.
All right,
Um,
darn. I'll stop the share and try again.
Yeah, try sharing the whole thing or sharing it.
Okay, share screen. Oh, there we go over there. There we go. How's that? Can you see it?
That's good.
Oh, goody. All right. So, Dr. Victoria Kaspi. She is a Canadian, age 54, born in Austin, Texas, moved to Canada when she was 7. She is an observational astrophysicist, physics professor, and founder and director of the McGill Space Institute. She did her Bachelor of Science at McGill in '89 and her MA and PhD in physics at Princeton in '93. She has held research and teaching positions at Princeton U, California Institute of Technology, NASA's Jet Propulsion Lab, MIT, McGill, and the Canadian Space Agency. From 2017 to the present, she was and is the Director of Gravity and the Extreme Universe Program at the Canadian Institute for Advanced Research, which I found out was in Toronto. So I'm not sure whether she does it remotely or whether she's actually at McGill, but I'm thinking she's at McGill. Her research centers on observational studies of pulsars and other neutron stars. She uses the largest and most powerful X-ray, radio, and X-ray telescopes in the world to study the physical behavior of neutron stars. She is one of the world's leading experts in the field of X-ray astronomy. Get this out of the way. A couple of interesting facts. A neutron star is so dense that 1 teaspoon weighs 100 metric tons. It's like taking Mount Everest, and trying to squeeze it into a sugar cube. There are thought to be about 1 billion neutron stars in the Milky Way. Victoria Caspi always loved math, so she chose for her career the highly mathematical nature of physics. She loves the nitty-gritty of research and having a great idea and pursuing it. At the time of completing her PhD, there was a revolution in X-ray astronomy, which she saw as an opportunity. She took a risk, and it was a huge change for her. The choice of her field of study within physics was based on logical reasoning. She wanted to work with smaller research groups. She wanted to enjoy the close collaborations, and she wanted to be able to get to know colleagues as friends. Because neutron stars are very dense, the study of them provides unique information about the properties of fundamental physics at such densities. Pulsars can rotate at more than 716 times per second. They are radiating radio waves. She describes them as a heartbeat in the sky. She names her computers after female Star Trek characters. Now, much more of her time is dedicated to educating students. She has supervised 90 student projects, helping a new generation to rise up in the research world. Advice to young scientists: attend conferences, talk to scientists, be open to interdisciplinarity, have a broad mind. She has 20 awards and honors, including the Gerhard Hertzberg Canadian Gold Medal, which she received in 2016. She was, at that time, the youngest researcher and the first woman to win the medal, which is Canada's top science prize. Just recently, she was named the co-winner of the 2021 Shaw Prize in Astronomy for her contributions to the understanding of magnetars, which are highly magnetized neutron stars linked to a wide range of spectacular transient astrophenomena. For example, a superluminous supernova. There she is.
So Marjie, are we expecting her early in the new year?
Well, that was my next question is, is she somebody that you think would be worth asking if she'd like to speak?
I think so.
I support that.
I will contact her.
Marjie, I've heard her speak. I was on the council of the Canadian Institute for Advanced Research when she was added to that group. And she's excellent. She would make a wonderful speaker. She's really a first-class scientist, absolutely. We can be very proud of her work and the fact that she's doing it in Canada. So definitely I would say thumbs up for her.
I think if we had her, that we should open it up to other RASC centers and other people who are interested to come into that speech, because she really is very widely known. So that would be great.
Could it be maybe to UVic astronomy students as well?
Mhm, mhm. I think so.
So we'll
Really
have to
wide
see,
open.
maybe we should see about getting the webinar account, the national webinar account that night.
Yeah, we're limited to 50 participants with our Zoom license, so we would need to provide for extra people. It's not a problem, just planning.
Yeah. So, yeah, well, thank you again, Margie, for this series. It's been very informative, and we've had one excellent speaker out of it. So that's, and I think we've got another, who have we got lined up next, is it?
We've got Emily Levesque. She's somebody from the University of Washington.
Right.
She's a recent author of something called The Last Stargazers. It's something that caught my eye a couple of months ago, and I've just sort of been reading it. It's wonderful, wonderful kind of travelogue of different institutions across the world that she's been to.
Great. Yeah. Well, thank you for inviting her.
And at the end of January, Tanya Harrison, the Mars gal.
Yes. So those are so we do have, those are the two speakers I referred to earlier in some introductory comments. So that's really good, and thank you for those who have arranged for them to join us. So it's very good. Any further questions for Margie, or are we ready for Dorothy? If you could get ready. And I guess Dorothy, you're on.
Okay, I'll see if I can share screen, share. No. I did the wrong thing. What did I do? You are sharing.
So if you just do the stop share at the top.
Oh, that's right. I did this before. I was going to do this right this time. Sometime I will. This is.
Yeah, it's an irritating thing with Zoom.
There we go.
Share the right thing.
That is absolutely right. Slideshow. Come on, slideshow. From the beginning. Just going to get one thing organized on my screen if I can to get it. Okay, so everyone see astronomers find a break in one of Milky Way's spiral arms?
Yes, we do.
Yes, you do. Good. Well, this, as I've given the best really overview of this is from on NASA's webpage. This link will take you to it. Our familiar Milky Way, there's the sun. So what is this all about? It's a good thing that the first thing I did not see was the original article, which wouldn't tell me much, or us, or me at least, anything much about what the story, a high pitch angle structure in the Sagittarius star cloud. Well, this is NASA's picture of it, blown up from this, with the sun down here, sun here, looking out towards the Sagittarius arm. This break, which is encompassed in the yellow oblong there, is the result of studies of the star-forming regions along the center of spiral arms, in which the Spitzer telescope, with an infrared telescope, is plotting. The data from it are still being mined, I guess you could say. And for this study, more than 100,000 stars in the region of the Sagittarius star cloud, and they found that within this region, 25 star-forming regions, and then using Gaia data to find the position and proper motion of these stars, they came up with this column here, which is of a space 300 light years long with an aspect ratio of 7:1. So it's a narrow cylinder with a pitch angle of 56 degrees. The Sagittarius arms angle is about 12. Pitch angle is, as is described or explained in the article, not in the other news items, is the curvature of for the Sagittarius arm. This curvature versus if the arm were a perfect circle. So for the Sagittarius arm, it's 12 degrees off, pitch angle 56, so it's way out of place, you might say, this spiral arm break, as they call it. The interesting thing is in this column are some famous bright nebulae, and I give the distances here. These are favorites of us all, I think, when we have a chance to see them. The Eagle Nebula at 7,000 light years, Swan Nebula at 5,500 light years, Trifid at 5,200 light years, and the Lagoon M8 at 400 light years. So going in from out about here for the Eagle to the Swan and the Lagoon, fairly close together. Whoops, sorry. And then the Lagoon, the Swan and the Trifid quite close together, and the Lagoon of either even closer. Now, these red symbols here show what made me very excited when I discovered this, and I guess made me think that it was really something that everybody should know about, is that these wonderful Messier objects, some of the brightest, most beautiful nebulae, but two of my three favorites that I pine to look at many times and would love to do really good drawings of, when I never will, but I try to get better. And number one is the Trifid M20, and number two, the Swan Nebula M17. So I thought it gave me an excuse to show a few pictures, and particularly of what an observer can actually see from a good sky. Not me, haven't done this yet, but from a good sky in a dark nebulae. This was my first attempt at the Swan, and many years ago, 2007, when Miles and I were in Namibia at a lodge, and when we weren't showing guest items in the sky with the telescope was a Meade LX200, and this was the lens that I was using, eyepiece I was using. Yeah, LX1200. Do I have this wrong? Yeah, sorry. Well, this is missed a number there. This was another thing about drawing. This for some reason, in this trip and this part of the trip, I decided to try using white pencil on black paper more than black on white, which is what I usually do and much prefer. This was about the first attempt. It's pretty crummy, but it was fun to see. And since then, I've seen a lot more, of course, and done some better sketches. But what I want to show you is this, which is a sketch made by Howard Banish and published in the Sky and Telescope September 2017 issue. The M17, the nebula with too many names. It's also, besides the Swan, called the Omega and the check mark, maybe something else. And I've included here, so this is a pencil sketch. Here's the Swan, which I think we've seen. Those of you who've looked from Chosen or with a good southern sky from here can see what looks very much like a beautiful swan against a dark sky field, but there's much nebulosity beyond this. And Howard comments how the dark molecular cloud how this is a dark molecular cloud. Remember, this is black on white, and how it appears. This is a scan of my original pencil sketch, which makes some of the outer bits of faint nebulosity easier to see, north down, west to the left. These bits of nebulosity show up nicely in his just inversion of the sketch on the left. And these really look like, I've had a chance to see this, haven't tried to draw it, but about 3-4 years ago, we had some good skies in Southern California in the mountains. They look like feathers being shed and molted from the swan. It's quite remarkable. It looks less like a swan, but I would dearly love to at least try my hand at that. And this is what one can see simply by eye, careful looking from good skies and a good hand at drawing. Sorry? Yeah, Miles was just saying he's seen, yeah, I've seen this. I haven't seen all of this, but I've sketched it. Trifid. This is one former, made from 2016 from our White Mountain site. My beginning sketch, which I plan to extend and do a better, better job out. I inverted this for some presentation we were doing somewhere, maybe when David and I were doing a sketching presentation up at the DAO. And you can see it's pretty crummy, but it gives an idea of what a first attempt I could see from a pretty good site, pretty good sky that time, but not, we sometimes get better. Here's what Howard Banish in the Trifid has sketched in the Trifid. And in this sketch here was made over many nights, several years with his 20-inch telescope, no filters. This is just observing by eye, but a total of 8.5 hours in the sketching and several hours for the finished drawing. I wish he'd published, and I think somewhere he has, or it's not on his website, an unlabeled sketch, but the label was interesting because it does explain some interesting features of the cloud, which I hadn't known about. The Trifid is so complicated and interesting to examine because it's actually two molecular clouds that are still colliding, which is an astrophysical rarity. It's only the second cloud collision H2 region ever discovered. And this is what perks up the interest of professional astronomers, because it's a small bit of the arm, but it could help lead to a better understanding of how the arms form and change. And then he gives some interesting bits in this. The Barnard 85 is moving towards us, and this cloud C away from us. And they've actually reversed their position in the last 1 million years. So if you think of 1 million years, so if you think about these kinds of things when looking at something as dynamic as this, it makes it look even more dynamic. And I'm just ending with Howard's inversion of that sketch, inverted and slightly colorized, which is something he started to do. And he's actually managed to occasionally see some color as he describes it. And I described in Astronomy Cafe some months ago how he's discovered that you may be able to catch some color in a very dark sky if you do it right. But as he says down here, and this is why everyone should get a chance to observe from a dark and transparent, a dark place, transparent night. The best view is 135, so not high power. And this was at the Oregon Star Party. So that's my dream of looking at that and maybe never getting this far, but I hope all of you get a chance to at least see this in a darker site than we have around here.
Those are works of art.
They really
as well
are.
as
They're extraordinary. And Howard is a very, very humble and interesting, gentle person. We know him from the Oregon Star Party, and I finally got up the nerve when I tried a couple of years. I tried to do and managed to complete enough of the advanced observers to list, sort of challenge that he put out for the Star Party to go and talk to him, and he pored over my pathetic sketches in my notebook of items that I hunted for. This was these lists you can use GoTo or tracking, or you can just do it entirely manual, which is what I was doing, the sort of separate categories. And we talked about the star hops that I had to find and got lost on before I got to the object, and then when I could try to find it. And he was just absorbed in it as much as I was. He's that kind of person, an observer. He's been doing this for basically all his life. I think he got his first telescope when he was 7 or something and started sketching when he was 14. But his website, I think, is really worth looking at and he has for, I hope that you people who are doing these magnificent photographs of some of these objects, which are magnificent. Of course, they're looking differently than we visual observers are, but you can see how much can be visualized. And when you, from a good sky, and kind of integrate the two views in one's mind. But I think his website would, it could interest you. He's done the Veil as a mag fairly recently, which is huge, and of course was a big mosaic of sketches, as I think your photographs are, many of yours. Anyway, that's it, a break. It's a small break. We don't have to call the galactic paramedics, but it's in a place that we all love to observe. And it's a really rich area. And in fact, it's probably richer because of this being shifted. Whatever causes these breaks, it's the first that's been observed in the Milky Way. These little feathers, they're called, have been observed in arms of some other galaxies, but it's much harder to study how they might form and just what they are, obviously. So that leads to the interest for the professional astronomers as well.
Dorothy, I just had a quick look for Howard's site and I couldn't find it, but if you have it handy, you throw it into the chat?
Yeah, I will. It's Howard Banish, and I think if you just Google Howard Banish, you'll come up with it, but
I haven't been able to find him either, so maybe you could give us the link.
Okay, yeah, well, I will do
great.
that. I'll try to do that, and I'll send it if I don't mess up. I'll get it in tonight. Otherwise, maybe Joe, I could send it to you and you could.
Sure, that's great.
Put it add it to the. Yeah, it'll be in his article in Sky and Telescope if you can get to those. His articles.
I think I found it. Is that the right one, Dorothy? There's a link in the chat. It looks like he's got those sort of drawings, and he's certainly got a big telescope he's pictured beside.
Yeah, the top first picture is his telescope, and then he has links to his articles and there are various. I think he's fairly new to doing this sort of thing on the web, but now he's I think assistant editor or regular associate editor for Sky Telescope, and it's getting a little more savvy about.
I spelled his last name wrong, that's why. So
okay.
I can see that.
I'm glad to know other people do that.
Well, thank you for bringing him to our attention, Dorothy, and those that's a very, and I guess that's, you could be right there, that's the reason why we see those things there is because of that break. So.
Yeah, and the whole area is so rich and bright because so much is going on there. All those hydrogen star forming regions shoved off at an angle.
Well, thank you again. If there are no further comments there, Randy, are you ready to roll?
I am indeed. Oops. Maybe not. Hold on, try that again. Share. Okay. So this is what I'm not going to talk about just because there's another more interesting story. But on YouTube, JPL came out with these two videos, one a couple of weeks ago and one just came out on Friday called Triumph at Saturn. And I loved them. And I was going to do a review of them, but just watch it. Be among the, 260,000 people have already watched the first part and 190 have already watched the second part. It's only 3 days old. Really gets into the personalities of the people who were making Cassini great. They go through the science really fast for a 2.5 hour show, but there's just so much there. But actually, what I'm going to talk about is dating the Viking settlement L'Anse Meadows with a solar flare. This is a story that has been popping up in my feed for a bit, and it's also deals with a subject that's close to my heart, which is carbon dating. And so I thought this would be good to kind of give you some background that you don't get in a quick view of what the story is. So the paper just came out on 20th of October. So this is really hot. And the many authors, several from Parks Canada, as well as a Danish team that got access to some of the wood that was excavated, decades ago, but has been kept preserved, and they were able to carbon date this wood. And just a bit about L'Anse Meadows, it was excavated in the 60s by this couple, Anstein and Helga Ingstad, and they kind of changed the story of Europeans coming to North America because they had lots of evidence showing that they actually came, what was it called? Eric the Red came over somewhere around 1,000 years ago, but they didn't have very accurate dating. And the main tool, which you may or may not know about, is carbon dating. And the way carbon dating works, and why I'm talking about it at a astronomy club, is so atoms are made out of protons and neutrons. Carbon, which is the fourth most common element in the universe, most of it, like almost all of it, was created during the Big Bang. And there's a very set ratio of carbon 12, that means 6 protons and 6 neutrons, to carbon-13, which is 6 protons and 7 neutrons. But there's this tiny, tiny percentage that you find, which is called carbon-14. So 6 protons, 8 neutrons, and it's not stable. It has a half-life of 5,730 years. And it keeps getting renewed because of cosmic radiation. What happens is, let me just go one page forward. You get these particles coming into the atmosphere, and there's lots of nitrogen in the atmosphere. And when you get a neutron, which is one of these cascading particles, banging against a nitrogen, then you often pop out a proton when you add in that neutron, and that changes nitrogen 14 to carbon 14. And carbon 14 then gets into the biosphere, either goes into plants or into animals, and then they die. And once they stop respiring, then the clock starts. And by measuring the decays, basically the ratio of carbon 14 to carbon 12, then you can see how old the object was when it stopped respiring, when it stopped being in equilibrium with the atmosphere. Now, the problem is, and they figured this out, in the 50s, they figured out carbon dating, a fellow named Libby. And in the 60s, they realized that it wasn't working perfectly. The assumption that the original ratio of carbon 14 to carbon 12 was a constant was not true. And so then what they started doing is measuring tree rings, and making a calibration curve. So you measure all the tree rings that you can find, and you know how old they are by counting. And so you measure them, you get the radiocarbon determination, and then you know how they really are, and you get this calibration curve. Okay?
Randy?
Yeah.
Randy, could I can't help it, but interject now. The real breakthrough was the carbon dating of the rings of the bristlecone pines in the White Mountains in the reserve above where we camp, because those are some of the oldest trees, the oldest or living trees, actually.
That's fantastic. So you've actually, you've been at these thousands of years old trees, eh?
Yeah, there are ones that are actually right, and they, by matching up a whole series of rings of different age, of trees of different ages, counting rings, have gotten back to 6,000, I think, very close.
Well, they go from
now
trees, then they go to annual laminations in lakes, and they're going back to about 30,000 years.
That's right, but
the trees themselves, 6,000 years sounds about right.
Yeah, and that led to, as I understood it, from what we've read a number of times about the bristlecone trees, which are going to survive when nothing else is left because nobody's up there to compete with them, is that this discovery of Schulman, who discovered these tree rings, the dating, it was what started the real recalibration of the carbon dating method. So anyway, I just couldn't help but inject that.
I am so glad you did. I just love the idea that you actually do astronomy at this very site where it is an astronomical problem. The thing is, what is changing the amount of carbon-14 that is created in the atmosphere? And it is changes not just in the number of cosmic rays that hit the Earth, but also how the solar wind affects the magnetosphere, which deflects away these charged particles. And so when they get deflected away, then less carbon-14 gets created, and you get these anomalies. And so they can see the 11-year cycle of the sun in there. But another thing that I want you to see is here in 1774, there's this huge break. And then there's a smaller one here at 993 AD. Now, I just want to talk a bit about calibration. And this is from a paper that I wrote. This is from a 2013 paper that we're looking at the ages of earthquakes in an inlet off Vancouver Island, Effingham Inlet. And I wanted to show a bit about the difficulties we were having with dating. So this is core 3, that's what the 3 is. And these are different depths in centimeters. And the carbon dates that the lab at University of California, Irvine produced for us. So, one at 143 centimeters down, then it came a bit over 200 years. And then you get down another 50 centimeters and it said it was 450 years, but you then have to calibrate it. So what you have to do is take the calibration curve, that funny line there, at 0. 0 is 1950. And the reason that they set BP, before present, at 1950 is that's when the atmospheric bombs started completely changing the carbon-14 in the atmosphere. But before that, there's also, for the last few hundred years, they've been burning lots of fossil fuels and everything. And basically, any object that formed after 300 BP, so that means the year 1650, you can't really use for carbon dating. This is something a lot of people say, wait, don't you just carbon date it? But it's only good for things that are more than about 4 centuries old. And what you get is for one age, so this one is around 200 years, it could be here, it could be, so it could be about 300 years old, it could be 150 years old, or it could be modern, and they all have the same likelihood. Whereas if something is around 420 years old, according to the carbon date, you know that it actually has a very tight uncertainty in its carbon date. And sometimes you get 3 peaks, sometimes you get 2, sometimes you get 1, and it really depends on how this curve goes. It folds on itself. So in Lansing Meadows, they had samples of carbon and of trees and bones and all manner of different things. And these are the likelihood of it being different ages. And from this, when they compiled it all, they figured that it was about 950 plus or minus 150 years. That was as well as it was dated until 2 weeks ago. And it's based on this discovery. First of all, this discovery that there was this break at 775 AD was discovered in 2012. And then a year later, they found this next one at 994. But this break here between the simple carbon age and the calibrated age, it happened in 1 year, and then it kind of decays over a decade or so. Anyway, what they did is they went and they sliced up these cores. They just take a thin core of these artifacts that have been preserved from the original archaeology, and they know that they are not, they were in a structure, so they weren't just random pieces of wood, and they were cut with metal tools. And the indigenous communities there did not have metal tools until the Norse came. So they know that this was post-contact, and they sliced it up, and with these new methods of carbon dating, which use a very, very little wood, they have these incredible precisions. They measured the age of each of these tiny, tiny pieces of wood. And I won't go through all of this, but they had 3 pieces of wood, which are colored in pink, green, and blue. And these are each year and the age against that calibration curve. And then in particular, there's that curve that was taken just of this time period around 992, 993 AD. And this is done from trees all over the world. They found trees that they can date very, very accurately all over the world, and they've made this curve. The blue curve is kind of averaging things out, but this is a very precise curve around here. And they compare these dates. They call this wiggle matching. It's an official term in carbon dating. And by wiggle matching, then they see that this part of the tree was at 993, and then you go to the youngest tree ring in these pieces of wood, and you end up that tree was cut down in 2021, and presumably then shortly afterwards went into the structures. So now, instead of having a uncertainty of 150 years, plus or minus 150 years, so 300 years total, they're down to annual precision. And it works with the histories that they have from the Norse histories. Thing that's really cool about 993 is there are very credible interpretations of medieval texts saying that there was a lot of aurora that year, and also in 1775. There's another one going back, I think it's 600 before the Common Era, was another one of these events. Now, what caused it? Oh, I just want to say, so this goes from all of this sort of uncertainty with the different types of samples to now, from those 3 trees, we're now seeing between, is it 1020 or is it 1024? But, it's very, very accurate. This is a blow up of this one little spot. So that's what happened with this study. Okay, so then what's happening with the atmosphere? And it could be that it was a supernova. There's a little bit of talk about whether the supernova that created the Crab Nebula in 1024, when was that? Observed by the Chinese, whether you see a ripple in the carbon calibration. And if it's there, it's pretty small. And the other clue is beryllium-10 and chlorine, I don't know, 23, something like that. You also see anomalies at 775 and 992 AD in the ice cores in Greenland and in Antarctica. So it's carbon, beryllium, and chlorine all are showing this. And the model that they're making is that it is not just any old flare, but it's actually a proton flare, which is directed right at the Earth. It's the way that they can model getting enough cosmic radiation into the atmosphere to create those neutrons, to interact with the nitrogen, to make the carbon-14, to make those anomalies in the carbon calibration curve. So we're actually looking at things happening on the sun hundreds and thousands of years in the past. And it's useful to note that there have been 3 of these events in the last 3,000 years, and the last one was 1,000 years ago. There's the Carrington event that happened in the 19th century, which if it happened today, like it blew up all the telegraph lines in the late 19th century. And if something like that one happens today, it would be really, really tough on our electric grids. But nothing compared to one of these big solar proton events. So let's hope it doesn't happen.
Thanks, Randy. Any questions for Randy?
Just one. Did you have a chance to compare the earthquakes that you detected with First Nations oral histories about any of those times?
Well, the one that is very clearly correlated is the Great Earthquake of 1700, and there's wonderful oral history right up and down Cascadia, where it's very clear that we're talking about the same event. What our study and our colleagues are finding is that there's about an earthquake every 500 plus or minus 200 years, a megathrust earthquake. That's a topic for another day.
Topic for a lifetime.
How far can you go back, Randy, before the measurement becomes so small that you can't go, you're extrapolating back?
Okay, the easy answer is they say 5 half-lives. With all of the different systems, they always say 5 half-lives, which puts it back to about 26,000 years.
Okay.
There are some labs that are saying they are able to see it even before that. But typically, when you get your sample back, if it is old, then they say greater than 26,000. That, you get a spreadsheet back from the lab, and that greater than 26,000 means that you have old carbon in there.
Right.
And it's 5 half-lives. And what, 2 to the 5 is 1/32.
It's x to the -5, right?
Yeah.
Thanks, Randy. That was interesting.
Thank you.
Really good.
I had an experience one time that left me feeling kind of weird. I was climbing in the Rocky Mountains, and I came across some neat fossils. And there was another fellow just coming up, and I pointed to these fossils and I said, "Look at these fossils, they're really quite old." And he said, "No, they're not." I said, "What do you mean?" He said, "Nobody knows, but the Earth has only existed for 2,000 years. I thought, well, it's the creationist maybe. So we got talking. I thought I wouldn't just dismiss him. I'd try to talk to him. The guy was a well-educated fellow from a physician, actually, from the prairies. But I could not talk him out of the notion that things like carbon dating were, in his view, just totally unproven. So I wish you'd been there to help me that day. I finally just had to say to the guy, "Look, we're just going to have to agree to disagree, because I thoroughly disagree with what you're saying."
When I have people come in my outreach activities that say things like that, I say, well, if God has given us such a great puzzle by putting in those fossils and setting the isotopes just like that, don't you think God wants us to figure out the puzzle?
Exactly. He gave us a brain too, or she did.
Those wouldn't happen to be the Burgess shales, were they?
The other thing I want to say that is just relevant to that, what I just said, is that the American Physical Society has from time to time put out information to help ordinary people distinguish between pseudoscience and real stuff. And they put out a book one time that was called Voodoo Science, and it was wonderful. It told the main message of the story was you don't have to be a scientist or a genius to recognize things that are not true. You have to use your common sense and look at the evidence and think about it and ask questions. And they've just started a new program. I don't know much about it yet, but I'm hopeful. They're teaming up with a medical group in the United States that's been trying to tackle some of the misinformation on the COVID vaccines. And they're trying to put out a more general sort of guideline for people to try to evaluate and figure out whether the things they're being told are correct or not correct. And I think it's good. I mean, science doesn't work when everybody just says, well, how many scientists believe this? Because it doesn't matter. Nature doesn't care how many scientists believe something. But what does matter is that we ask good questions and we try to find ways to figure out what is right or isn't right. And it was nice to hear you talk about the carbon dating because it reminded me of this trip I had up in the Rocky Mountains. So thanks again.
Yeah, we get people at public outreach looking through telescopes and basically telling us the same story. Oh, they can enjoy looking at the sky, and it's occasionally thoughtful and intelligent. It's hard to say intelligent, but they try to be thoughtful ones one can engage in. And I sometimes wonder if maybe if I have been able to spend a few minutes, if there aren't too many people lined up, whether it's made any difference. But that's something we're missing now. But if you don't start in schools and education using thinking about what you're being told, I'm afraid there's not too much hope.
So I'm referred to as the new age of the uneducatable.
Mm-hmm.
Yeah.
It's pretty hard to find a good argument that people will actually listen to if they've got their minds made up. But one argument I was thinking about recently is to tell people that the real power of science is that we get to change our mind when the evidence changes. Because
yes,
that
but
kind of
unfortunately,
gets at people that don't want to change their mind for any reason.
And that's scientists as well. I mean, if you talk about when the First Nations people started occupying the West Coast here, that's undergone a dramatic change in the last little while. Some of it due to carbon dating. Most of the original guys were talking that the Native people didn't show up here until after the last ice age, which would be roughly 10,000 years ago, because they couldn't get here. Well, they were seafaring. If they were seafaring people, they probably could have got here a hell of a lot earlier, maybe as early as 20,000 years ago.
Mm-hmm.
Yeah, and there's good genetic evidence from people all North and South America that go back, take the date back much farther than used to be thought.
Yeah. So new evidence, change your mind.
Yep, change your mind. But that can make you feel unsafe. That's why I think why it's, for some people, it's shunned.
Yeah.
Thanks, Randy. You provoked some good thoughts and comments there. If there's nothing more on that, Reg, are you ready?
I hope so. Can
Carry
I
on.
share the screen?
Please do.
Can you see a picture?
Yep.
A couple of weeks ago, I showed a picture that was taken by my cousin in California of a rocket blowing up. He also took this picture, and I show it because I wonder if that's a bristlecone pine. Do you have any thoughts on that, Dorothy?
It sure looks like it. I'm sorry I've changed my desktop picture to part of the Trifid Nebula because I used to have a bristlecone much like that with the Milky Way as my desktop, but it sure looks like it.
Okay, thank you for that. What I'm going to do is, first of all, I want to thank Randy for explaining radiocarbon dating to me. I didn't realize it was one, so controversial, and two, so complicated. And I'm going to watch your presentation again if Joe kindly records this event. So thanks so much for that. Randy asked me to give a bit of a talk about maritime bombs. I don't know if you're aware of it, but we had a record maritime bomb on Sunday, and I'll explain what that is. And so basically, I'm going to give you some background on this. I'm going to show some modeling of what we thought this weather event was going to be like, back it up with some observations, and end with some video. So I hope it doesn't go too long. The more I looked at it, I realized that this was worthy of a case study. I might be able to use it at other times as well. So first of all, for some background, a maritime bomb is a term, I wasn't all that keen on it, but what it really is an explosive release of kinetic energy that occurs when a low pressure system develops or deepens rapidly. Atmospheric pressure is simply the weight of the atmosphere overhead. And the units are weight per unit area. And the politically correct metric unit is a Pascal, but meteorologists talk in millibars. They never use Pascals unless they're on a public forecast venue, which is 1,000th of a standard atmosphere. And this was a brilliant unit, and then they messed it all up, but I'll get off that. So 100 kilopascals equals 1,000 millibars. So 1,000th of an atmosphere. The standard atmospheric pressure is 1,013.7 millibars, or 101.37 kilopascals. I'm sure we're better for all that. A low pressure system qualifies as a maritime bomb when the central pressure deepens by at least 24 millibars in 24 hours. So typically a real high pressure area would be maybe around 1050, maybe as high as 1,060 millibars. And the deepest lows in the Aleutians maybe get down to around 930 millibars. The energy sources for a maritime bomb, basically, one is gravitational potential energy, and it's kind of stored up, and I don't want to get into this, it involves the Coriolis force, but there's a band of the westerlies that circle the middle latitudes, and there's a buildup of mass, or almost like a slope of heavier air to the north that is due to the thermal contrast between the cooler polar regions and the warmer areas situated further south. And it's converted to kinetic energy when a wedge of cold air slumps southward. And you think of it in a way, it's almost like an avalanche or a landslide. It just can cause a change from potential energy to kinetic energy in that manner. Latent heat of condensation is another energy source, and it's released when water vapor condenses. Think about how long it would take you to boil a kettle dry. It takes an awful lot of energy to do that, but the energy of the vapor, water vapor, which is an invisible gas, when that condenses, the energy is released again in heat. And this occurs when moist air rises. When it rises, it goes up to a higher elevation, and there's less pressure around, and it'll cause it to expand. And in this is a larger volume. It's got the same energy, but the temperature drops. It cools. And as a rising air occurs when warmer air moves northward and climbs up a slope of cold air, and when it cools enough to the condensation point, it releases this latent heat. And it's a primary driver of hurricanes. Hurricanes usually breed or intensify over warm water bodies such as the Gulf of Mexico. That's where the gasoline for the hurricane really is. You got really high dew points, really warm water temperatures, and that provides the major energy source. Now, maritime bombs, they harness energy from both the potential energy stored in the westerlies and the latent heat of condensation. Usually occur in the fall and winter when the thermal contrast between the polar regions and the tropics are greatest. And they occur further north than hurricanes in the mid-latitude. So a hurricane rarely moves very far north unless it's following the warm waters of the Gulf Stream. It cools down fairly rapidly. And the other thing about a maritime bomb is it usually blows up on the East Coast when a disturbance moves offshore. There's less surface friction, and it takes off. On the West Coast, we do not have that situation, but the maritime bombs the low pressure system will quickly fill as they move inland due to frictional inflow in the circulation. At any rate, this is the forecast for 5 p.m. on Saturday evening on October, I guess that should say October 23rd. And there was Vancouver Island is located here, and this is a prediction from the Canadian Meteorological Center that evening. And there was a 968 millibar low here, which is already well developed, and that's also already considered a very decent low pressure system in our area. And then the forecast predicted, numerical forecast predicted that 12 hours later, it would drop to 948 millibars. So that's dropping 20 millibars, a prediction of 20 millibars in a period of 12 hours, which is way over the rate of 24 millibars in 48-hour criteria. So this is definitely a maritime bomb. I've never seen a maritime bomb in our area predicted with that intensity or have a low pressure area as low as that. So this really piqued my my interest. And then later on 12 hours later at 5 p.m. on Sunday, they predicted the low pressure system to increase to 954 millibars, still a very intense low pressure area here. These circular lines are lines of constant pressure, or millibar or isobars. And the tighter or closer these are spaced, the stronger the winds. So if we go back again, you can see it's a pretty intense system that we've got there. And so let's see how well we did here. What actually happened by 11 a.m. on Sunday, instead of, you remember the prediction was 948 millibars. They predicted at 12 Zulu or 5 a.m. The actual measured pressure was around 950 millibars, and 6 hours later at 11 a.m. it was 974 millibars, which in our business is extremely accurate. And then at 5 p.m. on Sunday, it went to 953 millibars, and you can see that the spacing is starting to weaken out a little bit. And then to 960 by 11 p.m. on Sunday. And on Monday morning, when we actually had most of our wind overnight on from Sunday night to Monday morning in the Victoria area, you can see it's 969 millibars and it's winding down, and it's predicted to move inland and weaken rapidly. So here's an animation from the wind program. This is using output from the European Center for Medium Range Forecasting, their model, just showing you the circulation around the low. And this was based around 8 a.m. this morning, showing how it's still circulating there. Let's see if I can get out of this. Uh-oh. Okay, so the other type of model I'm going to show you is a mesoscale wind forecast model. A mesoscale model is similar to the other atmospheric models, but it's a finer resolution, and it does away with one of the important simplifications of most of our larger scale synoptic scale prediction models, in that it allows the atmosphere to be compressible and instead of being hydrostatic. So here is an example. This is the output from this model, and these are arrows of the wind speed. And you can tell a meteorologist from an oceanographer is that meteorologists normally think about where the wind came from because they're looking into the wind to figure it out. An oceanographer will always look at where the water is going. So our vectors are normally different, but in this case, these are oceanography type vectors with the winds blowing in this direction. And the intensity of the winds, this is in kilometers per hour, and they're in colors. So green is not as strong as yellow here, and it goes up in the scale. So what I'll do is step this through quickly. For every hour, it starts out at, let's see, Sunday morning. That's when that low was around 948 millibars, and we'll see how this goes. You can see it, and you can see how complicated the flow is around Vancouver Island through Juan de Fuca Strait and Georgia Strait and stuff like this. These are just numerical predictions, but quite often they work quite well. So keep in mind that they're not absolute truth. So, but they're pretty interesting. And here around in the afternoon, we've got darker winds between 70 and 80 kilometers an hour showing up off the Washington coast. And if we go on further, we've got some stuff that's in the 80 to 90 kilometer range here. And so we'll carry on like this. And so right now we're in the evening of Sunday, and a lot of, in the Victoria area, we did not really have a lot of wind on Sunday, except a little bit in the Metchosin area. They had a fairly decent wind, but it really picked up overnight in our area. And so we have, this is a Harrow Strait going up into the Juan de Fuca Strait, I mean to the Georgia Strait area here. And not quite as strong a winds here. This is fairly typical. Sometimes you'll have an artery going up that does not necessarily involve Juan de Fuca Strait as much. And you can see the winds are jumping around. This is at around 4 a.m. and it gets a bit stronger. And I started looking at this intently around 7 to 8 a.m. Because we had pretty decent seas outside and this sort of stuff. And then you can see it kind of weakens off since that. So it's a tremendous tool. I'll just go back here and show you how we're seeing the wind shift as the low pressure system moves further north this evening. The winds are coming in from the west here, and we'll be having a westerly wind. It should be developing in our area now. And I think I'll leave it there. So I just wanted to showcase this tool because it's really quite remarkable. The one thing is that these mesoscale models, they say it's an experimental product. One reason for that is if you get a little bit of bad data in your initialization of your model, it can run amok. So you have to take these things with a grain of salt, but it seemed to work fairly well in this case. So now on to surface observations. Look at this buoy out here. This is a buoy, a Canadian buoy maintained offshore. And how it's held there is they got about a 10-ton block of concrete and about 3 miles of very thick rope holding this buoy in position, and it has all these weather instruments and wave height reading instruments. And what I'm taking this is a website from the US, but it was just a bit easier. And they have the wave height in feet here, but this is the latest time. This was at 4 p.m. on this afternoon, and we go down, it gets to older times. So on the morning of the 24th at 8 a.m., the winds were around 45, gusting to 56 miles per hour, a little bit lighter than a knot. But I just wanted to show you the wave heights here. The wave heights peaked at 26.9 feet. The highest wave height we've ever measured on the coast is around 30 feet, about 10 meters or so. So this is really quite an industrial strength storm there. It's just an amazing thing. And I will also, so we have another buoy called the La Perouse Bank buoy here, just southwest of Tofino. And if we show you that, things are, the peak winds are in the evening. If you look here, we've got 40 gusting to 51 miles per hour. There were gusts of 56 miles per hour here. And the peak wave height there was 28.9 meters. Feet rather, so a huge wave height there. I wouldn't want to be out offshore with that this time. So, and then if we look into the Victoria area, at here is Race Rocks here and Discovery here, and I'll be talking about the airport as well here. So if we look at the observations here at Race Rocks, they actually peaked early on the afternoon of the Sunday at 53 gusting to 60 nautical miles. But then on the day when they had somewhat stronger winds in the Victoria area, they were a bit more modest, although they were still fairly decent winds. And if we look at Discovery, which is just west of Oak Bay, you can see that the graph shows that the winds picked up kind of as predicted by the models in the evening of Sunday evening and maintained out. And then they started to diminish shortly after 7 a.m. this morning. But we had winds as 43 knots gusting to 55 knots there, and 48 gusting to 58 knots. This is a 58 miles per hour. This is a pretty decent wind for Discovery. And then we have Pat Bay. Their winds fairly strong for them, but they just do not get nearly as strong a winds as we get closer to Juan de Fuca Strait in the exposed areas of Haro Strait. So they're looking at gusts to 38 miles per hour at there. And just for completeness, I'll just talk about Sandheads and Sisters Islands on Georgia Strait to give you an idea about that. Sandheads, the winds throughout much of the day were 33 knots or 35 kilometers per hour, rather, gusting into 40s. That is enough to make landing at the Tawasin terminal very difficult. And based on their confidence in the forecasts, and the forecasts are based on this, in particular, this mesoscale model and things like that, they canceled the sailings almost a day in advance for this morning. And it turned out it was warranted. So that's good progress. Sisters Island, we were having winds in the northern end of Sister Island up around 55 knots there throughout most of the overnight period and into the morning. So that's that. And now Maritime Bomb Theater. Let's see if this will work. Are you still with me? Anybody there?
Yes, we're here. Yeah, I think we can see it.
Yeah, so this is a picture of the storm system, an infrared picture. And I think I've got, you can see it blowing up here and a spiral shape developing off Vancouver Island. And this is an enhanced image. And I'll stop that. And go to, this is the full Pacific in a visual image for Sunday. I'll start it up this way. This is the sun rising. And you can see the beautiful spiral, higher resolution imagery in the daytime period. This is the period of darkness, which emphasizes how wonderful it is to have infrared imagery as well. But you can see it going in there like that. So I'll stop that one.
Get out the telescope. It looks like a galaxy.
Yeah, well, that's a beautiful thing about this. And I'm glad you mentioned that. Here's a higher resolution blow up of the area around just offshore here.
Wow.
Just move it ahead. Yeah, you could just see it's coiling around like that. It's actually quite a beautiful an event, although it's unpleasant for many. So, and I wanted to show you what was kind of driving this and illustrate this idea of the thermal ribbon or thermal contrast, particularly over the Pacific. And I'm going to show you a thing called the 500 millibar chart. 500 millibars is half of the mass of the atmosphere is above us and half of the mass of the atmosphere is below that level. And basically Vancouver Island is located right here. And we have a long, strong stretch here. And these lines of constant height of pressure are a reflection of how intense the temperature contrast here is. And this is the breeding ground for intense extratropical cyclones and storms like we see here. So this is going to take place over a long period of time. It goes back to Tuesday, and I'm just going to start it here. And I'll just stop it here. And you can see off of Vancouver Island, we had a storm spin up on Thursday. And I think that was a storm that probably caused the freighter to list and lose 40 of its containers and all of the drama associated with that. And then we'll carry on a bit. And I'm just going to move us back here. And I want you to notice this thing that's coming off of Japan, a little kink in the contours here. And if you can keep your eye on that, that moves across extremely quickly. And what it does is it amplifies the system that caused our maritime bomb from developing. Sometimes when they're embedded like that, they might have some more tropical source of moisture in it and really add more gasoline to the development of the system. But you can see it exploding here. So, and now it's winding down now. So this is the end of our period. So that passed was about 6 days of time that we elapsed. And then we're going to go forward here. And I just want you to see something here. And this is should cause you to rejoice. This is a big ridge of high pressure, and this is good news for us. We might have usable skies on Halloween. So I'm very reckless to make this prediction, but there you have it. And with that, I think I'll stop everything. Oh, I've got one more picture, sorry. One more movie. Yeah, this was taken this morning in Oak Bay. And it shows the big waves coming in. And it was quite a spectacular scene. And there were logs there that have been in this file for about a decade or more, and a lot of them were dislodged and set to sea there. So it was kind of pure Tofino in Oak Bay this morning. So pretty powerful system. With that, I'll stop it. And I'll stop the share. And there we are.
Thanks, Reg. Any questions for Reg?
Don't we have magnificent scientists in our midst? Just wonderful. Thank you.
So I don't know if the skies will clear enough for your AGM. Are you planning anything for that?
Well, we were going to see if we could open the plasket, but we'll check it out and see. We'll have to wait. You think that we might be able to on Saturday night?
Well, it's very reckless for me even to mention it. So I'm losing it.
Okay, I won't do
it. Looks
that.
like there could be some clear skies coming, but who knows?
Yeah.
Reg, I'm sorry I didn't have a video camera down at Holidine Point. The breakers coming into Arbutus Cove outdid what you caught this morning. And Arbutus Cove is definitely getting a lot deeper than it was. The waves in Harrow Strait were spectacular.
That's one of my favorite places. I'm going to have to go there during a big storm. That's good. Check that out.
Well, thank you again. So I guess I'll put up the, we've got 2 photos from Edmonton.
Yeah, so I'll give you a quick running commentary. So this is from Denny Boucher from Edmonton. And he said that he'd been learning how to use PixInsight, and he had some previous data on M31. So he had a little bit of a go at it. This is with a GT71, which is a William Optics refractor with about it's a triplet with about a 400 millimeter focal length, 71 millimeter objective. And that's 60 frames at a minute a frame and stacked up. So that's actually not a bad picture for a first shot with Denny working with PixInsight. And then the second one is from Alistair Ling. And this is the coat hanger and some surrounding stars. And apparently at their Astro Imaging Cafe this week, one of their members, Gary Snow, had given them a methodology for putting color back in any overexposed stars. So Alistair tried this, and this was the end result. And this is a combination of images that were, some were taken at a very dark site out at Tofield, Bordeaux 3 or 4, and then some from his backyard in Edmonton at Bordeaux 5 and 6. But it gives you some idea of, maybe we have to talk to Gary guys about how he takes the color back into his stars. And then next week, I hope to have a little short presentation, I guess you could call it, on the trials and tribulation of Roman eunuch and his manufacture of the altitude and azimuth drive wheels. Basically the ones that I showed you last year, where they had deformed through heat treatment and he was trying to fix them, they weren't fixable. So thanks to Bob Drew and a fellow that he contacted in the States, he managed to rebuild the horizontal wheel and the sector wheel. And I've got a few photographs I can show you of that. So the telescope is back on track now in terms of getting it finished. It was in hiatus for virtually a year. So next week I'll give you a little shot of that.
It must have been crushed to find out they couldn't use that. That would have put them really back. David, you were going to tell us about what's up this week.
Yeah, there's a number of things happening. I think, John, you're leading the astrophotography SIG this Wednesday. So hopefully people will be bringing their planetary subjects with them that evening. Thursday evening is kind of a bit of a mixed thing. I was trying to find a spot to have an information meeting for the RASC light pollution survey, and it was difficult to find any space. So I'm kind of sharing space with the makers group on Thursday night. There's a Zoom link that's been sent out to anybody who has expressed an interest to the RASC pollution, light pollution survey. So if you haven't received it, send me a note and let me know, and I'll send that along to you. If you're not presently part of that group and you're interested now, then contact me as well. So the makers group is going to meet at 7 p.m. till 8. And then the information meeting for the light pollution survey will start at 8 o'clock. And Lauri, I think you have some information for Saturday night again.
Yes, I was just going to, I'm sorry, I didn't get in to put my name down on the list, but a Saturday night, we're going to be having the FDAO annual general meeting, which will just be like fairly short, starting at 7 o'clock. We have to do that for the charitable work that we do. And then at 8 o'clock, we're going to be having Dr. Brenda Matthews, who's going to be talking about her work with ALMA. And I'm wondering if I could just see if, I don't know whether this will work, but may I share the screen just for a minute, Chris?
Yeah, please do.
Okay, see if I can get this to work. So she's going to be talking about the 10 years of ALMA. It had its first photograph 10 years ago, and then she's going to be working on finding out her work on planet formation and circumstellar disks. And so we'd love to have all of you join in. It will be for those of you who are not members of the FDAO, then you can get it on our YouTube channel, and we'll get that out on the FDAO website. And we'll maybe, Chris, if I can give that to you when we've got that up, can I send it out to you to put up? And for those of you that are going to be in on the meeting, you will have already been given a link for registration because we have to do the voting. It's just like our own RASC meeting. We have to have a registered list of voters. So please come along. We're going to be having at the end of the meeting after Brenda Matthews speaks, David is going to be giving us a little bit of some stuff on EAA, and if it's nice, we'll also open the Plaskett for just a little bit. So we'll see. They're doing I'll just stop the share here. They don't know whether or not people are aware, but they are right now in the process of re-illuminizing the Plaskett disc, the Plaskett mirror. Sorry, I'm not sure whether it's going to be finished by Saturday, but we'll see whether or not that's right. So there's a great big hole. There was a big hole in the floor that was there for quite a while. The other thing, just to let people know, because I think it's really important, is that the NRC is going to, so James DeFrancesco and group is going to be meeting face to face with the elders from the Wasanic Nation on Friday morning for the first time. We've had a couple of meetings with some of the leadership council, but we're actually going to be having the elders who are going to be coming up to the center and doing for one of the first times having a tour of the Plaskett telescope. Hopefully the floor will be back in, and the center of the universe, because we're looking at really trying to get some connections with the FDAO. I mean, we are on their lands. I mean, there was the telescope is on their lands, and we'd like to get a little bit more collaboration and connection with that group. So I just let you know, I'll keep you in touch with what's happening with that. We're all excited to have that happen. Thank you.
Thank you.
So Lauri, I
Yes.
just joined them the other day, so I will have missed getting that link.
Oh, I'll make sure that you get that.
Thank you.
Yeah, no problem. I'll make sure that I'll write that down so I remember. Okay. Thank you. Okay. Anybody else, you can certainly join us, and we can send you a link to get in on the meeting on Saturday. Thanks, everybody.
Okay, and our last item, Brock, you had a couple of photographs?
Yes, I do. They're a couple weeks old, but I realized I hadn't shared them. They were taken in October, so let me get them up. Can anyone see M33?
It is there.
There we go. Yeah, this is a shot I took on the 8th. And it's the second time I've taken a shot of the Triangulum galaxy. This one turned out much better than my previous attempt. And it's pretty spectacular how much hydrogen star forming regions are visible in this. It's just amazing, all of these. It must be, if you live on a planet around a star in M33, there's probably some pretty amazing nebula if you up close.
What
Brock, are you-
camera are you using, Brock?
This is with a one-shot color, the ASI 2600 MC.
Are you using the MDZ here, Brock?
No, this is without any filter.
Okay.
Just wanted to capture everything. And it was a pretty good night. There was no moon, or not much moon, and I don't have much light pollution, so I went completely without filters.
Very nice.
Yeah, very nice.
What night was that?
It was on the 8th
Okay.
of October.
Friday night, was it? Yeah.
Yeah, I think it was a Friday. There was a couple nights there, and
Yeah.
I managed to get out. And the next night, or was it the next night? I guess it was. No, it wasn't the 8th. It was the 11th. I got my small scope out, and I got a shot of the Sol Nebula, Westerhout 5, which is up in Cassiopeia.
That was the night of all the aurora, wasn't it?
I don't know. I missed out. I should have gone. And,
Yeah, so did I. I was out at Pearson, but the trees blocked the north, and so.
yeah, I have
Couldn't see
terrible
that.
views of the north here. So,
Yeah. Wow.
but yeah, it was also a really good night. The seeing was excellent,
Yeah.
and got some good. This was with the NVZ filter.
Yeah, there's some really nice detail in the central region. Often when you see this image, it's kind of vacant. It doesn't have that kind of detail that you have there.
I was pretty happy with it.
Yeah, it's very nice.
Good overall. It'd be nice to do it in narrowband mono and be able to do sort of a Hubble palette to get a bit more of the varying, colors that you might pick up from sulfur and stuff. But I think for a one shot, it came out okay. And as the weather's been terrible, that's all I've got. So
Hang on to those. They're both beautiful.
Yeah, they are. They're
Yeah,
great.
nice, Brock.
Great. Well, thank you very much, everyone. It's a very interesting evening of topics. So thank you to everyone who presented. And if you have items, don't forget to let me know. So we'll be back next week for our first Astro Cafe in November.
Thanks.
Anyways, and then if you're in those other items that David mentioned or the FDAO presentation on Saturday, remember there's some things this week. Anyways, stay safe, everyone, and we'll see you next week here.
Thanks,
night.
Chris, for doing this every week.
Good
You're
night.
amazing.